Not audible.
Yes, sir. Once ask. Okay, sir. Once ask.
Now, okay. Okay. Okay, so how was the paper? No response. Nice. Okay. 150 physics. Good. Good. 158. Very good. Track 2 was slightly difficult. I was thinking the people will get maybe lose marks, but people got the good marks. Good. 140. Vikram. Good. One weekend is over. Again, next weekend tension is start. 140. Good. Okay. Okay then. Try to maintain 120 plus. Okay. Syllabus of this week is the kinetic theory. I think there is a phase exam. So previous syllabus will also come, unit dimension. Present new syllabus is the kinetic theory of gases. That maybe it will get over today. Any question, explanation in exam, you ask. If any question you required. Paper I don't have now. Okay. (180) and 645. Very good. 180 in physics. Very good. Okay. Good. And 645. So means you lost more in chemistry or bio? Okay. Chemistry. Okay, no problem. Okay, so I have completed, I think, all velocities, root mean square velocity, average velocity formula I discussed, and most probable velocity also completed. And in the last I made the graph. Okay, that was a maximal distribution. Okay, so one small problem we will do. Suppose I am saying I have the two gases. A and B, molar mass. Suppose I am taking the capital M, its molar mass is 2m. Okay, RMS velocity of this is V square. They are at same temperature. Okay, so we have the two gases A and B. Molar mass of the gases are m and 2m, and RMS velocity of the B I have given V square. Okay, if mean square velocity of A in x direction is V dash square, then find V dash square upon V square is equal to, then find the ratio of the V dash square upon V square. I repeat the problem that two gases I have, A and B, molar mass of the gas A is the m, molar mass of the gas B is the 2m, RMS velocity, RMS root mean square I have given. Mean square velocity for the B I have given V square, and they are at the same temperature. So if I am saying the mean square velocity of the A in the x direction is V dash square, then we have to find the V dash square upon V square. Try. What is the answer? 2 by 1. Okay. Vikram, you have not read the question properly. Root 2 is to 1. Okay. Any other answer? 2 is to 1. Trishal. Okay. Any other answer? Why the people are getting 2 is to 1? Okay. They are taking the under root 3 RT by M. So under root 3 RT by M. So velocity of A will come. What is the mean square velocity of A? Mean square velocity of A. So root mean square velocity is the under root 3 RT by M. Okay. Temperature is same for both. So temperature factor we will not see. Molar mass of the gas B is double. Okay, you are correct only. Okay. So what is the root mean square velocity of the A? Under root 3 RT by molar mass of A. Molar mass of A is the M. Molar mass of B is the 2M. So what is the mean square velocity of the A? First say this answer. What is the mean square velocity of the A? Who will say? Mean square of the A. No, in the terms of V square, directly you can say, na, because temperature is same, molar mass data I have given. So in the terms of V square, what is the mean square velocity of the A? So velocity of the A upon velocity of the B, you can say what? Under root of molar mass of B upon molar mass of A, because it is inversely proportional to the under root M. So mean square I am asking, so VA square upon VB square, what you can say? MB upon MA. MB is the double, so 2M upon M. So M and M cancel out. What is the VA square you got? 2 VB square. Yes or no? So I can say the mean square velocity of the A is what? 2V square. This everybody got or not? Molar mass is the half, okay? But it is a velocity is inversely proportional to under root M, inversely proportional to root M. But I am asking the velocity square. So velocity square will be inversely proportional to M. Are say yes or no? Velocity inversely proportional to root M. So velocity square will be inversely proportional to M. Now mass is half, so velocity will be double, okay? So that is a 2V square, okay? Now, but I'm not asking the ratio of the velocity of A to the velocity of B. I'm not asking this. What is the question? If mean square velocity of A in X direction is V dash square, then I'm asking the ratio of V dash square upon V square. So who is saying the answer is 2 is to 1? They are saying the velocity of A, mean square velocity of A upon mean square velocity of B, that they are saying the answer is the 2 is to 1. But I'm not asking the mean square velocity of the A upon mean square velocity of the B. No, Gagandeep, still you have not understood. In the derivation, if you remember one thing I said, Vx square bar is equal to Vy square bar is equal to Vz square bar is equal to V RMS square by 3. Remember that point of the derivation? I said I will give the question later. In a derivation, I said Vx square bar is equal to Vy square bar is equal to Vz square bar is equal to V RMS square by 3. Everybody got that point? I write the relation V square is the Vx square plus Vy square plus Vz square. From that I said due to the random motion, we can say in all the direction velocities will be equal. Okay, now remember na? Now who will say what is the mean square velocity of A in X direction? So that will be the VRMS of A square by 3. VRMS of the A square by 3. Yes or no? So I can say what? V dash square. V dash square. That is equal to VRMS of A by 3, because I am only asking particularly for the X direction. So in any direction, mean square velocity is the 1/3 of the mean square velocity. Are yes or no? Everybody got this step or not? I am asking the mean square velocity in a X direction. So that will be the 1/3 of the mean square velocity. Now this I can say what? V dash square is equal to VRMS square of A, that I got 2V square. So 2V square by 3. So what is the V dash square by V square? You will get what? 2 by 3. Not understand. Okay, I will repeat again. You forget the derivation or you remember the derivation? Okay, first I will say, in the derivation of the pressure formula, I said that Vx square bar is equal to Vy square bar is equal to Vz square bar is equal to Vrms square by 3. This step you remember or not? Oppo A83. This step you understood or not? This I use in a derivation. Okay. Now here you can see Vx square bar is equal to what? Vrms square by 3. Okay. So Vrms of the A, what I got? Vrms of A, Vrms square of A. That I got 2V square. Why? Mean square of the B I have given V square, but mass of the A is the half. That's why Vrms square of A I got 2V square. This step you got. This step is okay. That I have written here. Okay. Now Vrms square of A I got 2V square. Now from this relation, Vx square bar of A, what I can say? Vx square bar of A is equal to what? Vrms square of A by 3. Vrms of A is what? 2V square. So 2V square by 3. This velocity I gave V dash square. So V dash square I can say what? 2V square by 3. So what is the V dash square upon V square? That is a 2 by 3. Got it or not? Oppo. I'm asking the ratio of the mean square, because V dash what I gave? V dash square I gave mean square velocity in the x direction. It means it is a basically what? It is a Vx square bar, and Vx square bar is the what? Now for all direction it will be the same. Now that I use in a derivation. Then we got the formula pressure is the 1 by 3 m into n by v into Vrms square. Okay. So V dash square means I am saying the Vx square bar, and Vx square bar will be the Vrms square by 3. Vrms already we got 2V square. So 2V square by 3 you got. So ratio will come 2:3. That's why I don't give the difficult question. You ask her, give the tough question, tougher question. Vikram was asking one day. Okay. Now everybody got or not? Okay. Okay. So root mean square velocity, temperature effect, mass effect, maybe they can give only the temperature effect. So I directly said it is a directly proportional to under root T. If the two different gases, so under root of T by M. Maybe last one question I gave, you can write next one the same type. Find temperature. I just want to check. Find temperature at which Vrms of oxygen gas is half of neon at minus 23 degree C. Tell neon atomic mass you can take 20. Find temperature at which Vrms of the oxygen gas is half of the neon at minus 23 degrees C. Tell the answer fast. So here different gas I am saying and different temperature. Then we can say what? Vrms is directly proportional to under root of T by M, because here different gas, so different molar mass and different temperature. That's why we can write V directly proportional to under root of T by M. Okay, then V oxygen upon V neon. That I can say what? Under root of temperature of oxygen upon temperature of the neon into molar mass of neon upon molar mass of oxygen. I can write. Okay. This step is okay. 100 Kelvin or degree C? 100 Kelvin. 100 Kelvin. 100 Kelvin. Okay. So V oxygen we got what? V oxygen is the half of the neon. So we will get V oxygen is the V neon by 2. So this ratio you will get 1 by 2. That is equal to, now you can do the square on both sides. So temperature of oxygen they are asking. Temperature of neon they have given minus 23. So when you convert into the Kelvin you will get 250 Kelvin, because temperature of the neon is equal to 273 minus 23, that will get 250. Okay, into molar atomic mass of the neon, that is a 20, and this is the what? 32. Now this and this cancel out. This is the 16. So temperature of oxygen 4 will get cancelled out by the 16. So here you will get the 4, and here is the, it get cancelled out. So temperature of the oxygen you got 25 4 is a 100. That is a 100 Kelvin. Good. Okay. Everybody got 100 Kelvin? Simple question. That similar type of question I discussed in the last class also. Okay. Completed. Okay. Now next is the topic is the degrees of freedom. So what is the degree of freedom? So suppose kinematics is going on. Any particle is free to move only in particular direction, x direction or y direction or z direction. Okay. So we can say in how many ways the particle can move. So it has only one option, that it can move in a straight line. Okay. So basically what is the degree of freedom? Degree of freedom is what? It is the number of independent way. It is the number of independent way the molecule can possess energy or molecule can move or any object can move. It is the number of independent way the molecule can possess energy, or we can say in the terms of motion, molecule can have motion. Number of independent way the molecule can possess the energy. That is called the degree of freedom. Independent way. Independent means like I cannot take any random. If we ask for difficult, you are giving more difficult. Okay, leave it. Okay, so what I said, what is the degree of freedom? Degree of freedom is the number of independent way the molecule can possess energy. Okay, we have to find independent way, means like x and y, these two directions are independent for each other. Any vector will have the x component. So what is the x vector component in a y direction? 0. Like suppose I am taking any vector in the x direction. So what is the component in the y direction? 0. So that x and y, z, these are called the independent direction. So in the linear motion, we will have the only 3 independent direction, x, y and z. Yes or no? So what is the degree of freedom? It is the number of independent way the molecule can possess the energy. If you want to write, you can write. Now, if the molecule is like constrained or restrict to move in a one direction only. So when it is a moving in a one direction, it can have the energy in a one direction, we can say. So what is the degree of freedom? 1. So if the molecule is restricted to go in a straight line, so what is the degree of freedom? 1. If it is a moving in a plane, then like I am walking on the floor. So floor means maybe I am walking like this doesn't matter. But how many degrees of freedom? So if I resolve my motion, so I can resolve in the 2 independent direction, x and y. Yes or no? So how many degrees of freedom I will have? In a motion in a plane, you will have the 2 degrees of freedom. Motion in the space, how many degrees of freedom you can have? 3 degrees of freedom. This everybody got or not? Otherwise I have to repeat again. So I am saying what degree of freedom is the number of way the molecule can possess energy. Independent way the molecule can possess energy. Independent means it should not, like, I cannot take the component that whose, like, this is moving in this direction. So I will say only one, because I can resolve this motion in a two direction like this. So these two are the independent way. X and Y are independent. Z are independent from each other. So in a linear motion, we can say always we write the maximum component is what? X, Y, and Z. So how many independent ways we can get? 3. Okay, so if any molecule, if any atom is free to move only in the x one direction, so it has a 1 degree of freedom. If it is restricted to move in a plane, so in a plane, how many degrees of freedom? 2. If it is a free to move in a space, how many degrees of freedom for the linear motion? 3. Understood or not? So suppose I am saying any insect is crawling on the board. Any insect is crawling on the board. How many degree of freedom it may have? Insect is crawling on the board. How many degrees of freedom it may have? 2. Why? It will move in a plane, not the 3 dimension. So in a plane, how many degrees of freedom you will have? 2. Understood? If it is a bird is flying in a space, how many degrees of freedom it may have? 3. If linear motion we are talking about, so 3. Everybody got? Okay. So now I can say what? For translation motion, for linear motion, how many maximum degrees of freedom you will have? In a translation motion, you will have the 3 degrees of freedom, X, Y, and Z. Vikram, translation doesn't mean the only X direction. You can, it have the, like this is a motion. So you can resolve this motion in a X direction, Y direction, as well as Z direction. So motion is the linear, but the independent ways is what? 3, X, Y, and Z. Understood? So for the linear motion, how many degrees of freedom you may have? 3. Similarly, for rotational. So rotational, like suppose this is a pen. This is the x-axis, okay, x-axis, y-axis, and z-axis. So this is a rod or anything you are taking. So it can rotate about. Suppose this is the x-axis. You are putting like this, okay, perpendicular to the x-axis. So it can rotate perpendicular to the x-axis like this. So about x-axis, it will have the rotational kinetic energy. About y-axis, it can rotate like this. You can put here and it will rotate like this. Okay. So about y-axis, it can rotate. Similarly, about z-axis, suppose it is a z-axis. So about z-axis, it can rotate like this. Okay. So about x-axis, it is free to rotate. Y-axis, it can rotate, or z-axis, it can rotate. So how many rotational degrees of freedom it may have? Like this may rotate, this may be rotation, okay, like other way, it will have the 3. Okay, so in our rotational, how many degrees of freedom it will have? 3, because it can rotate about x-axis, y-axis, or z-axis. So rotational degrees of freedom will be 3. So 3 linear, 3 rotational. Okay, and in a problem maybe they will say a person is moving on the floor. How many degrees of freedom it may have? If a person is moving on a floor, how many degrees of freedom it may have? 2. Floor means plane. Plane means how many degrees of freedom? Independent. So independent is a 2. Understood or not? Who said 1? In a floor means if I am saying particular direction, like only one direction I am moving, restrict to move only one direction, then I will say okay, x direction only, y direction only, then one. But otherwise in a plane, how many degrees of freedom you will have? 2, because 2 independent xy plane or yz plane or zx plane. So xy plane means 2, yz plane means y and z 2, zx plane means z and x 2. Okay, who said 1? God. Okay. So 3 translation you may have, the particle may have, and 3 rotational it may have. Okay. Next is the vibrational degrees of freedom. So vibrational degrees of freedom we consider in a gas. Particularly we are dealing for the gas. For the gas, vibrational degrees of freedom we consider at a high temperature, because at the low temperature their vibration will be small. So their vibrational energy we can ignore. But high temperature their vibrational amplitude will be more. So that's why corresponding to the vibration we consider 2 degrees of freedom. I repeat again, vibration degrees of freedom, first is a linear or translation degrees of freedom, 3. Rotational degrees of freedom it may have 3. Next is the vibrational degrees of freedom. So vibration degrees of freedom, always for the vibration it will have the 2 degrees of freedom. Vibrational kinetic energy, vibrational potential energy. But vibration degrees of freedom we consider only at high temperature, because low temperature their vibration will be negligible. Okay. So when they are particularly they are saying consider the vibrational mode also, or they are saying at the high temperature, means they are giving the hint you have to consider the vibration also. Then we will add, otherwise we will always ignore the vibrational degrees of freedom. Everybody got or not? So 3 translation, 3 rotational, 2 vibrational, but vibrational we will only consider at high temperature. And for we say that vibration we are considering 2, but in the problem also they can change. Okay. So like in the JEE main they have given the so many large number of vibrational mode. Okay. So that whatever they are giving we have to take it. Otherwise we will consider vibrational degrees of freedom 2. Understood? But that we will consider when they are mentioning, or they are saying at high temperature, means they are giving the hint to consider the vibrational mode. Okay. Everybody got? So for the degrees of freedom we can say like translation mode is translation or linear motion. Then how many degrees of freedom you will take? 3, x, y and z. Okay. Similarly for rotational, then you will take degree of freedom 3. That is a moment of inertia about x-axis, moment of inertia about y-axis, moment of inertia about z-axis. Because rotational kinetic energy you will learn in the rotational half I omega square, where I is the moment of inertia and I we define about a axis. That's why about x-axis Ix, y-axis Iy, z-axis Iz. So energy what you will get, half Ix omega square, half Iy omega square and half Iz omega square. No need to remember that, later you will learn in the rotational. Okay. And third is the vibrational. So degree of freedom corresponding to this is the 2. Okay. But it consider at we will consider this at high temperature. In NCERT that they have given CO2, they have given like carbon monoxide, that their vibration degrees of freedom we consider at the low temperature also. Direction for vibration, vibration may be any direction, like vibration is like this, about the mean position it is vibrating. Okay. So already translation motion is there, so already direction we have considered in a translation. Okay. So for the vibration we will say that 2 potential and 2 degree of freedom. One for the corresponding to the vibration kinetic energy, other is the vibration potential energy. Okay. So if they are not mentioning the number of the vibrational degrees of freedom, then we have to take what? 2 degrees of freedom corresponding to vibration. Completed? Okay. Any doubt in this? Today people are sleeping after the breakfast. Okay. Okay, then for the gases we have to remember result directly. So first one is the monoatomic. How many degrees of freedom? So monoatomic means single atom. Single atom means there is a no meaning of rotation, because suppose I am saying this is a one atom. Okay, this is a gas atom. Okay, how it will rotate? Because we are taking as a point. We are taking the molecule atom as a point. Point, there is a no mean of rotation of a point, because you will say axis is passing through this, it is rotating. You can see the rotation. No. So when it is a monatomic, there is a no meaning of the rotational degree of freedom. Yes or no? So it can only, point can only translate. Okay. So point can only translate. So we can say what? Translational is equal to 3 and rotational will be 0. Okay. Vibration we have to consider at high temperature. No need to write that. Second one is the diatomic. So how many degrees of freedom for diatomic? Translation, always that is a 3. So translation is the 3. Rotational. Rotational is the 2. Why? For the diatomic, why we take 2? Like suppose this is the diatomic molecule. One molecule is here, one atom is here, one atom is here. Okay. So it will lie along one axis. So it will, suppose it is lying along any axis, that axis you can take as x. Okay. So perpendicular to that, one axis will be y and other axis will be z. So this is the diatomic molecule. So it will lie along one axis. So one axis either you can take, that is a x or y or z. Okay. So it take one direction. So that's why its moment of inertia about that direction will become 0. Like suppose you are taking here, molecule is here. So this is the x-axis, this is the y-axis, this is the z-axis. So about x-axis, its moment of inertia will be 0. Why? Moment of inertia, no direction. Moment of inertia basically mr square. So from the x-axis, no distance is there. So directly r you can say 0. So moment of inertia is 0. So it will not have any moment of inertia about x-axis. It will have about y, it will have about z. So which axis it is lying, about that axis moment of inertia 0, so degree of freedom is 0. Rest two perpendicular direction you will get. So that's why degrees of rotational degrees of freedom is 2. Everybody understood or not? So for the diatomic, translational 3 and rotational 2. Vibration I am not talking about. At high temperature directly we will add 2. Okay. Okay, and third one, polyatomic. Polyatomic linear. Here I am saying linear, but in the exam if they are using the polyatomic only, so we will not consider, we will always consider the polyatomic non-linear till they are not mentioning polyatomic linear. So polyatomic linear means it is lying number, it has the more than 2 molecule, but they are lying in a one line. One line means along one axis. One axis, which axis they are lying? Their moment of inertia 0. So 1 degree of freedom become 0. Now only 2 axis remaining. So 2 rotational, 3 translation. So if it is a linear molecule like the diatomic, then 1 degree of freedom will get 0 in a rotational. Then translation will be 3. And rotational will be 2. Okay, but if they are saying polyatomic, and directly we have to remember, no need to think more, polyatomic non-linear. Most of the case they are not saying the polyatomic, then they are not mentioning linear and non-linear, we will always take non-linear. Okay, then translation is 3 and rotational is 3. Okay, everybody got or not? So monatomic 3, diatomic total 5. Okay, so we will say the total. Here total 6. Okay, so monatomic 3, diatomic 5, and polyatomic non-linear 6, polyatomic linear is 5. Directly you have to remember. No need to remember individually also. Okay. So polyatomic, non-linear, linear, they are not mentioning. So 6. Diatomic 5, monatomic 3. Completed. Now after the degree of freedom, law of equipartition of energy. So Maxwell that has given the law of equipartition of energy means the energy of a gas equally distributed among all the degrees of freedom. Energy of a gas equally distributed among all degrees of freedom. So suppose I am saying the total energy of the gas is E, okay, and it has a degree of freedom F. So each degree of freedom, how much energy it will have? E by F, E by F, E by F, like that. So what was the law? Energy of a gas equally distributed among all degrees of freedom. Okay, so energy or internal energy, whatever you can say. Internal energy of gas, that I will write as a U. Internal energy of a gas equally distributed among all degrees of freedom. Okay. Okay. So we can say what? Energy of molecule for each degree of freedom, that is equal to 1 by 2 kb into T. For each degree of freedom, 1 by 2 kb into T. That you have to remember because we got the 3 by 2 kbt. So for each degree of freedom, energy of the molecule we can write 1 by 2 kb into T for each degree of freedom. Okay. So if it has F degree of freedom, how much energy? For each degree of freedom, that directly you have to remember 1 by 2 kb into T. I am talking about the one molecule. One molecule, 1 degree of freedom, 1 by 2 kb into T. Okay. So for F degree of freedom, for N molecule, suppose I am saying, for F degree of freedom and N number of molecules, what you will get? F degree of freedom for N molecules. So F degree of freedom, F by 2 kb into T, and for the N molecule, then you will say into N. Yes or no? Okay, 1 by 2 kb into T into N for F degrees of freedom and N molecule. Then for F degrees of freedom and N moles, 1 mole first, 1 mole. Tell. For 1 mole, what you will get? 1 mole means how many molecule? Avogadro number. So N you will say what? Na. N you will say Na. And Na into Kb is the R. For 1 mole means how many molecule? Na, Avogadro number. So you can say what? F by 2 Kb into T into Na. And Kb into Na I can say R. So what you will get? F by 2 R into capital T. Okay. So then we can say that you have to directly remember also energy of internal energy of n moles of gas. If F degree of freedom, so I can say F by 2 nRT. So 1 mole F by 2 RT, or n mole directly we can say F by 2 nRT. Understood? So each degree of freedom 1 by 2 kBT. From that we got the n moles for F degree of freedom F by 2 nRT. If they have given the number of molecules, then we can use what? F by 2 kb into T into n. For molecule, if they have given F by 2 kb into T into n. Otherwise from the here also you can find. If they have given the number of molecule, the number of mole you can write as what? N by Na, R by Na, what you will get? Kb. Then you can say F by 2 Na n into kb into T. That same you are getting here. Because number of mole formula everybody know. So no need to remember that 4 different formula. Directly you can remember one this and one this. For each degree of freedom 1 by 2 kb into T. For n moles F degrees of freedom, so F by 2 nRT. Okay. Okay. And nRT, what we can say? nRT is the PV. So sometimes we will use the formula this also. F by 2 PV. They will not give the condition of mole and temperature. They will give the pressure condition, pressure and volume. So that nRT I can say from the ideal gas equation P into V. So we can use what? F by 2 PV. Understood? Okay. So number 5 I can say change in internal energy for given moles of a gas. Gas given means F constant, given mole means N constant. Then I can say what? Delta U. Delta U will be equal to what? F by 2 NR delta T. Okay. And NR delta T, what I can write? I am asking the change in internal energy for given mole of a gas. Means temperature is different. Temperature is different means you will say F by 2 nRT2 minus F by 2 nRT1. So what is the T2 minus T1 you will get? F by 2 NR delta T. And NR delta T, what I can write? P delta V. That is a mistake student do. NR delta T is not P delta V. NR delta T is the P delta V only when the pressure is constant. Trishal, Geetika, Vikram. NR delta T is not P delta V. NR delta T is the P delta V only in a particular case when pressure is constant. NR delta T, because PV is equal to nRT. Suppose you differentiated on both sides. So P delta V when you can write when the pressure is constant. Otherwise you have to differentiate pressure as well as volume. Getting my point or not? Then you will get what? F by 2 P2 V2 minus P1 V1. That is a NR delta T. Why? P1 V1 is the NR T1. P2 V2 is the NR T2. So what is the NR T2 minus T1? P2 V2 minus P1 V1. P1 V1 is the NR T1. P2 V2 is equal to NR T2. Now subtract NR T2 minus NR T1. NR you can take common, T2 minus T1. So NR delta T is the P2 V2 minus P1 V1. Now pressure is constant, then P you can take common, V2 minus V1 is what? Delta V. So when pressure is constant, then I can write P delta V. Otherwise I will always use P2 V2 minus P1 V1 when we have to find the change in internal energy. Understood? Okay. So what I said, we have to remember basically only 2 or 3 formula. One is the per degree of freedom 1 by 2 kb into T. For F degree of freedom n moles, F by 2 nRT. Okay. And change in internal energy, we can say F by 2 nR delta T or F by 2 P2 V2 minus P1 V1. Okay. Now simple question. Suppose I am asking if oxygen gas is at temperature T Kelvin, then find internal energy of 1 mole of oxygen gas. Tell fast. Direct formula based question. What is the answer? Five RT by 2. 15 RT. Five RT by 2. Five RT by 2. That has asked in that 2021. In a matrix match, 4 question was there. One was the pressure, P is equal to 1 by 3 Mn into Vrms square. Second was internal energy of the kinetic energy of the molecule. So that was a 3 by 2 Kb into T, and 1 mole oxygen gas. So 1 mole oxygen gas, directly you can take what? F by 2, U is equal to F by 2 nRT. So I have given the oxygen gas, so degree of freedom will consider 5. 5 by 2, number of mole 1. So 5 by 2 RT. Okay. Next question. Find internal energy of gaseous mixture of 2 moles of neon, 3 moles of nitrogen, and 1 mole of, suppose ammonia I am taking, NH3. Tell what is the answer at temperature T. We have the mixture of the gases, 2 moles of neon, 3 mole of nitrogen, and 1 mole of ammonia at temperature T. What is the internal energy of the mixture? So total internal energy, what we will say, U total is equal to neon is a monatomic. So for the monatomic, you will say F by 2. F by 2 means 3 by 2. How many moles they have? 2 into R into T. This is for the neon. Okay. F by 2 nRT. So degree of freedom for the neon, monatomic 3, and number of mole 2 into RT plus N2. N2 is the diatomic. Diatomic, what you will take? Degree of freedom 5. 5 by 2 into how many moles? 3 into RT. Okay. 27 by 2 RT. 19 RT by 2. Okay. Plus ammonia as a polyatomic. Polyatomic, we will take the degrees of freedom what? 6. Then 6 by 2. How many moles? 1 moles into RT. Okay, so this is a 6, 5 3 is a 15, 15 plus 6 21, 21 plus 6 27. How 17? 3 2 is a 6, 5 3 is a 15. So 15 plus 6 21, 21 plus 6 27. So 27 by 2 R into T. That is the answer. Okay. Got it? Everybody, any problem? Directly formula base F by 2 nRT. Okay. Now next. If a container contains oxygen gas at 300 Kelvin on heating up to 500 Kelvin, all oxygen molecule dissociate in atom, then find energy needed or energy supplied Hmm. 300 joule. So in a container oxygen gas, we have oxygen gas. Mole is also required. Contain. You can take 2 moles of oxygen gas. 2 moles of oxygen gas at 300 Kelvin on heating up to 500. All oxygen molecule dissociate into the atom. Then find energy supplied. 600 joule. Okay. Any other answer? So here what we will do, same container, the gas is enclosed. Okay. So when we are heating, volume is not changing. In the thermodynamics we learned when the volume is changing, so work done in expansion will be also there. But here only what is happening, internal energy of the gas is changing. So whatever the energy we are supplying, that is changing the internal energy. Okay. So initial internal energy we have to write, and final internal energy we have to write. The difference of that we have supplied. Okay. So first we have to find the internal energy initial. Okay. So what is the U initial? So U initial we can say it has that for 1500 joule, 1000 joule, 600 joule, 600 joule, 0. Initial internal energy Jyoti is 0. Why 0? It is at 300 Kelvin. So you will say what? Initially you will say F by 2 N1 R T1. Okay. Initially it is an oxygen molecule. So how many degrees of freedom? 5 by 2. How many mole it has? 2. R is the R. What is the temperature? 300. So what we got? 5 3 is a 1500 R. Jyoti, got it or not? Answer was 0. Okay, I will check. Okay, UF, final internal energy. So finally what will happen when it will get dissociate into the atom? So one molecule will give the 2 atom. So what is the final mole? What is the final mole? What is the final mole? 4. Why? Each atom will give the 2 atoms. So finally the number of molecule will become number of atom become double. Number of atom become double. So number of mole also get double. So final mole you will take 4. Okay. So 4 by 2. And what is the degrees of freedom? Now after dissociation, it will become monatomic. And monatomic, how many degrees of freedom? 3. Okay, so now degree of freedom you will take 3. So first I am taking that is a 3 by 2. Number of mole we can take 4 into R, and final temperature is what? T2, that is a 500 Kelvin. Okay, then what you will get here? This is the 2. So you will get 6, 5 the 30. So 3000 R. Okay. Anybody has problem in this? Okay. Now UF I have, UI I have. So what is the delta U? Delta U, you can say what? UF minus UI. So if the UF is lesser than UI, it means energy get released. And UF is more than UI, so we have to supply the energy. So here UF is more than UI, so we have to give the energy. How much? UF minus UI, that is a 3000 R minus 1500 R. Then what you will get? 1500 R. Now R you can put the 8.314, then you will get the answer in a joule. If you put the 2, then you will get answer in calorie. So calorie, what you will get? 30,000 calorie. Why 3 by 2? 3 by 2, why? Because when the oxygen get dissociate, so it will become O, monatomic, single O atom. Now, so O atom is what? It is a monatomic gas. So that's why monatomic gas, what you will take? How many degrees of freedom? 3. Got it or not? Who asked that? Why I am writing 3 by 2? So oxygen, initially oxygen molecule was the diatomic. Now you dissociate means it become atomic gas. Atomic gas means it is a monatomic. Monatomic means degrees of freedom 3. And initially suppose 2 moles means 2 Avogadro number of molecule. 2 Avogadro number of molecule. Now after dissociation, it will become 4 Avogadro number of atom. So number of atom become the double. Atom becomes the double. So what is a mole now? Mole you will say number, total number of atom upon Avogadro number. So what you will get? 4. Infinix. Because mole, how you calculate? Mole is the molecule when you are talking about. So number of molecule upon Avogadro number. That is a mole. When you have the atom, then you will say what? Number of atom upon Avogadro number. If you have atomic gas like neon, so neon you will know molecular weight. You will say the atomic weight. Okay, so number of atom upon Avogadro number is the number of mole of neon because it is a monatomic gas. Similarly here O formed. O is the monoatomic. So what is the mole? Mole is the number of atom of the O upon Avogadro number. Then number of mole will get 4. Got it or not? Infinix. So initially we have the 2 Na, 2 Avogadro number of molecule. Now after dissociation, one molecule is giving 2 atoms, so we will have the 4 Na. 4 Na of the atom. So 4 Na of the atom, so how many mole? 4. Okay. Huh, 3000, 1500. Oh, okay, sorry, 3000. Or you will take that 2 calorie. Okay. So that is a 300 calorie. Okay. 300, not 300, 3000. Because we are getting 1500 R na. So R either you answer is the joule, so you can put 8.314. But here, suppose if they are asking the calorie, so R you can put 2 calorie. So 1500 into 2, you will get the 3000 calorie. Okay. Completed. Okay. So now next topic is the mean free path. This whole internal energy we will use in our other chapters also. Okay. So what is the mean free path? Up to this, any problem? No. Okay. So suppose I am taking the gas molecules, they are inside the container. So what is happening? They are moving randomly inside the container. So they are colliding with each other. Okay. So suppose it collide with this. This is the first atom. This is the second. Suppose I am taking this. Okay. So first atom collide with second. So between first and second, when it is going from 1 to 2, it is not colliding with anyone. Okay. So it is a free. That time it is a free. Okay. Then this path, how much distance it travels, that is without any collision. So that is called the free path. That is called free path. Why? In that path, it is not colliding with anyone. So distance traveled by the molecule or atom in successive collision is called the free path. Distance traveled by molecule between any collision, that time is called free path. Free path means it is not colliding with anyone. But all the collision will not be the identical, like it collide with one, it traveled this distance. So but 3 is the farther from this. So 3 is the far, so it will travel more distance to reach to the 3. Okay. So this free path, all free path may be the different. That's why we define the mean free path. Mean free path is the average of the distance traveled between the two successive collision. Average distance traveled between the two successive collision, that is called the mean free path. Okay, mean means the average and free path is the distance traveled between the collision. Everybody got or not? Okay. So it is the average of average distance traveled between two successive collision is called mean free path. Okay. Okay. So generally we will write the mean free path as a lambda. So basically our basic formula, what we can say, mean free path is equal to what? Total distance traveled in n collisions upon number of collisions, that is a n. So total distance upon number of collision, that we can say as a mean distance. So mean distance is the mean free path. This everybody got or not? So free path means that is a between two collision, what is the distance it is traveling, that is a free path. But we cannot find the each and every distance, that's why we define the mean free path. Mean free path is the average of the distance traveled between the successive collision. Okay. So basic formula from the definition, we can write the formula lambda is equal to what? Total distance traveled in the n collision upon number of collision. Okay. Say yes or no. Okay. Now another term we defined, mean free time, or that is also called the relaxation time. Relaxation time or mean free time is what? Free time means it is not colliding with anyone. So between the two collision, sometimes it is free because it is not colliding with anyone. So that time is called the free time. And average of all the free time is called the mean free time. Okay. So that we will represent by tau. Mean free time is what? It is the average time between the two successive collision. So average distance between two successive collision is the mean free path, and average time between the two successive collision is the mean free time. Means it is at that time it is free. It is not colliding with anyone. Okay, then mean free time formula, what I can say, mean free time, that is equal to, time is the distance upon speed, so that will be the mean free path upon speed of the molecule, that is the VRMS, average speed we take as a VRMS. So relaxation time or mean free time is the what? Mean free path lambda upon VRMS. So tau is equal to lambda upon VRMS. From that, proportionality and everything we can decide. Okay. So mean free time, that is the time is the distance upon speed. Distance is the mean free path and speed is the what? VRMS. Okay. Okay. And one mean free formula, you have to learn mean free path formula. So mean free path lambda is equal to, maybe last year you marked up, 1 upon under root 2 pi d square into small n. Here I am using the small n. Small n means, what is that small n? Who will say? What is a small n? Number of collisions. Number of collisions. No. That I have used here. It is a different. Total distance traveled in any collision. That is a different thing. If you are getting confused here, we can use the different symbol. Otherwise, you will take this as n. Because number we generally write as a n. That's why maybe you are getting number of molecule. Any other? I said when I said the pressure, I said when we are using the capital N means you will use the number of molecule. When we are using the small n, we have to, that time my example I also gave for the free path. I gave the two example. One is the drift current and the second one is this. Remember, so when I am using the small n means it is a number of molecule per unit volume. So here small n is the number of molecules per unit volume. So that is small n is the capital N by V. Okay. And D is the diameter of molecule. Mean free path is an important concept. Okay. So suppose I am saying how the mean free path depends on the radius. Mean free path is directly proportional to radius square, inversely proportional to radius, inversely proportional to radius square. For a given number of molecule per unit volume, it is inversely proportional to r to the power 4. How r to the power 4? Our diameter and radius relation is not the d is equal to not the r square. What you will get? For given n, we can say what? Lambda is inversely proportional to d square or inversely proportional to r square. Why? Diameter is equal to 2 into radius. 2 will go with the proportionality. So it what? Lambda is inversely proportional to the r square. 4r? How 4r? What is the meaning of this 4r? In physics, lambda n is constant. So other thing is also constant. So we can say what? Lambda inversely proportional to d square. D is the diameter. Diameter is the 2r. Okay. But when you take the square, 4 will come. But 4 will go with the proportionality. I am asking the proportionality relation. So we can say what? Lambda inversely proportional to d square or lambda inversely proportional to r square. Okay. Yes or no? Okay. Okay then. So lambda, this formula we have to remember, lambda is the 1 upon under root 2 pi d square into small n. Is small n right? So remember, so that's why you will say small n is the capital N by V. 1 upon under root 2 pi d square into n. Okay. So it means it depends on the diameter and number of molecule per unit volume. This number of molecule per unit volume we can write in another way. We know the ideal gas equation. PV is equal to number of mole. Number of mole I can say what? Number of molecule upon Avogadro number into R into T. PV is equal to number of mole I can write as the number of molecule upon Avogadro number into RT. R by Na I can say what? K. So directly I said, if you remember, I said the ideal gas equation we can write in this form. PV is equal to NKT. Okay. This V you will shift here. So N by V, what you will get? P upon KB into T. This is what? Small n. So small n we can write as P upon KB into T, where KB is the Boltzmann constant. Okay. Then we will get what? Lambda we can say. Lambda is equal to 1 upon under root 2 pi d square. In the place of n I can write as P by KB into T. KB into T will go up. So that is a KB into T. So if they have given the condition of the temperature and pressure, they have not given the number of molecule per unit volume, or then we can use this pressure relation. Lambda is the KB into T upon under root 2 pi d square into P. So just remember that n, small n we can write as a P by KT. Okay. So at constant temperature for a molecule, lambda inversely proportional to P. At constant pressure and given molecule, lambda directly proportional to T. All proportionality you can find from here. Okay. Everybody got or not? Okay then. So now we will do some question. Suppose I am saying we have one container and the gas is enclosed in the container. Okay, listen question carefully. If I have one container, in the container some gas is enclosed, okay, and the mean free path I am saying lambda. Mean free path is lambda. If I make the temperature of this container, temperature of the gas double, if temperature of gas is doubled, what will be the mean free path? If temperature of the gas is doubled, what is the mean free path? 2 lambda. Lambda. Two lambda. Doubled. 2 lambda. Answer is a lambda. Because now I ask the temperature effect. Okay, so you will say, think, okay, T is coming up. So that's why temperature get double. So lambda get double. But when container is closed, we know that pressure is directly proportional to temperature. So when the temperature get double, pressure also get double. There is no effect on the lambda. Lambda will remain same. So in these cases, you will directly connect with the small n and the small n. Now D, diameter of the molecule, I am not changing. Small n is what? Number of molecule per unit volume. Same container, same number of molecule. So is the small n is changing? Suppose I made the temperature 4 times. Is the small n is changing? Small n is the number of molecule per unit volume. That is changing? I'm asking. Small n, number of molecule per unit volume. That quantity is changing or not? Just say the answer. If I made the temperature double, that quantity will change. No. Why? Same container means volume is V. Same number of molecule, it means number of molecule capital N. Now number of molecule per unit volume is same. Diameter is not changing with the temperature. So diameter is same, small n is same, lambda will change. Say yes or no, lambda will change. No. So you are thinking about the only formula like T is in the numerator, Ti double. So that's why lambda get double. When the T will get double, pressure will also get double. Why? Because at constant volume, we have learned in the Charles law, at constant volume, we will get what? P directly proportional to T, Gauss law. So P directly proportional to T means when you double the temperature, So they will not say the pressure effect. You have to think. So when temperature get double, pressure also get double, no effect. Okay, so that's why it is better directly connect with the small n. Okay. Okay. Second thing, suppose I am saying gas is enclosed in the container. Now I am increasing the temperature. All the molecule get dissociate into the atom. All molecule dissociate into the atom. And I made the temperature double. All molecule dissociate into the atom. Initial mean free path was lambda. What is the mean free path now? But in that case, D effect also we have to think, no? Because diameter of the molecule will also get changed. What is the effect? Means increase and decrease. Directly I cannot say double or 4 times, but if I'm asking it will increase or decrease. Decrease. Repeat again. Temperature increased. Then number of molecule dissociate. Okay, that is a different, because here we have to see the small d effect also, because we have to think that diameter will get what. So it is better that, like, suppose I am heating and some molecule get escape out. We increase the temperature and molecule escape out. Then mean free path will increase or decrease. I increase the temperature, some molecule escape out, then mean free path will increase or decrease. Decrease, increase. So in that case, you will say what? Directly we will see lambda is equal to, maybe somebody is thinking that temperature effect. Okay, we will not think about the temperature effect. Why? Gas is going out, so pressure will also change. If somebody is thinking only temperature, I am increasing the temperature, so temperature effect, increase the temperature, but gas is going out. So what will happen? Gas will go out, so pressure will also may decrease. Pressure will, because moles is decreasing, so it is possible that pressure may decrease. Temperature is increasing, that is okay. So that's why P and T effect we will not see. Directly which effect we can say? So lambda we will go through the formula 1 upon under root 2 pi d square into small n. Now on heating, D is not changing. Now small n is the number of molecule per unit volume. Directly it is the safest if you focus on the small n. Because here temperature is increasing, so pressure is also affecting. So I cannot see that only temperature effect. Pressure effect also I have to see. But by using this formula, some gas is going out. If the gas goes out, number of molecule per unit volume decreases. Why? Container is same. If mole escape out, some gas escape out, no need to see the temperature effect. Directly I can say what? N will decrease. Okay, if N decrease, so lambda will increase. Yes or no? So temperature effect and pressure effect, both are the connected with each other. So that's why directly we cannot say from the pressure and temperature. It is easy from the N. 1 upon 2 root 2 pi d square n. Now gas escape out means some molecule escape out, but the container is same. So container is same, so what will happen? Number of molecule per unit volume decreases. If n decreases, so lambda will increase. Got it or not? Say yes or no. Okay. So this type of conceptual question means try to relate with a small n. If you are unable, means pressure, temperature condition, both they have given, both value they have given, then we can use the formula Kb into T upon under root 2 pi d square into P. Okay. That question I will discuss in our next class. Okay. So conceptual question, try to relate with a small n directly. Okay. Okay. Bye bye. phase is also there. Okay, next class remind me, I will again explain, no problem. Okay.